Hello everyone, welcome to this video. I'm Amit Raheja, working as assistant professor in AISSMS IOIT. Move to the next slide, that is analysis of truss by using method of sections. Now in this method, this is a method which is quite I should say yes easier, and time it reduces the time required for analyzing the truss. Now, this method is mostly used when we are required to find out the member forces of few members. Let us say a truss may contain 10 members, so we are interested in finding out the magnitudes of only 3 member forces. So in that case, if we proceed by method of joints, then it would be very laborious, it would be more time consuming. So instead we will go for using method of sections. So the first two steps for method of sections are the same: check the stability of the truss, draw the free body diagram, and apply conditions of equilibrium to find out the support reactions. Now in the free body diagram only, we need to mark the uh, member forces that are required to be calculated, and then draw a section line which will pass through these members. What is the condition for this section line to pass over the members? The section line should not cut more than 3 unknown member forces, which are to be determined. Now it may happen that a section line is cutting 3 members, but only 2 are required to be found as per the question. Okay, so it doesn't matter, we can cut the truss along that section. Now what are we trying to do? We basically are trying to cut this truss in two parts depending upon the number of unknown members required, and then we are going to apply all the three conditions of equilibrium on any one part of the truss. Now let us say we are cutting the truss from the center, so it will divide the truss into two parts. So in the next step we will draw its FBD of any of the section, that is the left hand side section or the right hand side section, and we will apply all the three conditions of equilibrium. Okay, so select a section, cutting maximum 3 members such that uh, all the 3 are unknown members, and it should not cut more than 3 members. Okay, so this is the condition. With reference to the imaginary section, now there are two parts of the truss, as I told you. Select either of the parts and draw FBD of that part. By assuming forces in the cut members as towards the section line that is acting away from the joint, as we had assumed in the previous slides for analyzing the truss by method of joints. We had assumed all the forces to act away from the joint. So in this method of sections also we need to assume that the forces are acting away from the joint. That means the members are carrying tensile force. So see to it that the free body diagram that we have drawn of any part of the section of the cut truss, it should represent the support reactions, the external loads which are acting only on that part, and the unknown member forces. Then lastly we need to apply all the three conditions of equilibrium to find out the member forces. Now apply summation of moment equal to 0 at different joints to find out the internal forces. Okay, and there is an important tip. A section can be cut more than 3 members, but the unknown forces should not exceed 3. Now as I told you that it may happen that more than 2 forces are acting on the joint, that is more than 2 members are connected at a joint. So it may happen that more than 3 members are getting cut by the section line, but the unknowns should not exceed more than 3. So this is care that we need to take care while drawing the section of the truss. Now let us see how to use this method by using one example. So this is a truss. Over here it is said that we need to determine the forces in members FH. FH, you can see it's an inclined member at the bottom. DH is the vertical member. EG is the horizontal member, and BE is again the inclined member. Now, in this example, you can see SI system of units is not used. You can see the measurements and the magnitudes of the forces, they are given in kips, and the distances between the joints as well as the supports is mentioned in feet. So either you can keep the same system of units and analyze the problem, or you can convert the units, that is feet to meters and kips to newtons or kilonewtons, as the case may be. But over here I have kept the same system of units. So firstly, we need to draw the free body diagram, and as you can see, I have tick marked the members, that is DH, FH, EG and BE, which are to be found by using method of sections. Next, we need to find out the support reactions by applying all the three conditions of equilibrium. Now, one thing, we have drawn a section line over here, represented by a red colored section. You can call this section as section 11, section XX, or you can name it accordingly. But note that the members DH and FH, one is inclined, the other is vertical. So what we can do is that we can pass a cutting section that we'll see ahead. The nature of this section line can be a straight line, or it can have a curve, as may be required depending upon the arrangement of the members. Okay, so that we'll see ahead. Now we have calculated the support reactions. Now we need to cut the truss, and we need to apply all the three conditions of equilibrium. So over here you can see that we have drawn a cutting section between the members BD and CE. Okay, and now we are going to consider the top portion of the section. As you can see in the right hand side, we have shown the top portion of the section line. So over here you can see we have drawn the truss as it is, and we have shown only those member forces which the section line is cutting, that is TBD, TBE and TCE. In addition to that, we have shown the external forces which are acting on the joint, as it is a free body diagram. So whatever be the external forces acting on the joints, we are required to show them in the free body diagram. Next, now to analyze or to find out the member force TBE, what we can do is that you can apply summation Fx, Fy and moment equation. But it is mostly advisable that you firstly apply the moment equation, so that we can quickly get rid of one of the unknowns or two of the unknowns. Now over here we have an option of calculating the moment about the joints A, B and C. Now if you calculate the moment about joint A, the member force TCE will be 0. So we are left with only two unknown members, that is TBD and TBE. The second thing is that you can also calculate the moment about the joint C. Okay. For that case also, the member force or the moment of the member force TCE will be 0. Then again we are left with the two unknown members TBD and TBE. So you can select either of the joint A or joint C for calculating the moment. But over here I have selected joint A, and by using the moment equation, you can get the value of CE. Now why we have selected joint A? Because TBD, that is the line of action of TBD, is passing through A, so its moment will be equal to 0. Also TCE is it's passing through the joint A. Again, the moment of TCE will also be 0. So we are left with only one unknown member force which is required to be calculated. So simply by rearranging the equation, we can get the value of the member force TCE, and we got the value as negative, which implies that our assumption is incorrect. This member BE is carrying a compressive force. But again, I'm telling you, again, I'm repeating that we shouldn't change the direction of the forces that we have shown in the free body diagram. We need to keep them as it is. We need to carry the negative sign with these member forces ahead if required in the equation. For finding out the unknown member force HF, we are drawing a cutting section between the members HD and IG, and considering the bottom portion below the section line, we have drawn the free body diagram, and we can observe that TIF, TIG are passing through point I, and we are required to calculate the unknown member force THF. So instead, using the two equations summation fx and summation fy, we'll directly use summation of moment about point I, so that the two forces TIF and TIJ, as they are having the line of action passing through point I, their moment would be 0 about point I. Hence we'll be left with only one unknown THF. So by finding out the moment about point I, we get the value of THF, that is 2.5, and in this way we have found all the unknown member forces. So depending upon the number of unknowns, it may be required for us to use more than one section line, and in some problems one section line would be sufficient for finding out the unknown member forces. So this condition varies from problem to problem. Next, I'll provide you with some practice problems. You can pause the video and note down the problems for your practice.